So let us see software engineering question and answer. These are descriptive type of question and answer. So the first is define the following. That means modeling. What is modeling? Now you want to show to your user something. Or see, you have to make something you don't want to show to the user. You want to make it the way you have presumed for what you do for that. You make a model. You create a model out of it. So you create a model from the user requirement. So modeling is the translation of a requirement into the blueprint of a system to be used. Okay, and the functional model is created to gain a better understanding of the actual entity to be built, that is functional and behavioral model. So what is software engineering? What is software engineering? Software engineering is the establishment and use of sound engineering principle in order to obtain economically viable software that is reliable and works efficiently on real machines. What are the characteristics of testing strategies? Testing strategies, characteristics. So let us see the characteristics one by one. Testing begins at the component level, means the smallest level, and works outwards towards the integration of the entire computer-based system. And from the beginning to the end, there are various points in the SDLC. So different testing techniques are appropriate at different points of time, or points in time. Testing is which is conducted by the developer of the software. Okay, large software, and it can also be conducted by an independent test group. IV&V, you must have heard about it. Independent validation and verification. Then we have testing and debugging. These debugging and testing, these are different activities, but debugging must be accommodated in any testing strategy. Whatever byproducts are there for testing, it will be debugged. A strategy for software testing must accommodate low-level tests that are necessary to verify that a small source code segment has been correctly implemented, as well as high-level tests that validate major system functions against customer requirements. What is project schedule in general? Project schedule. So we are talking about the project schedule. Software project scheduling is an activity that distributes estimated effort across the planned project duration. If this is, say, the timeline of the software, then allocating the effort to specific software engineering tasks. Say requirement analysis will be done by a requirement analyst. Then we have designers, then coders. So it is important to note that this schedules, it evolves over time. This is time. During early stages of project planning, a macroscopic schedule is developed, not entirely. This type of schedule identifies all major software engineering activities and product functions wherever they are applied. So as the project gets underway, each entry on this macroscopic schedule is then refined again into detailed schedule. So we have specific software tasks which are required to complete an activity. They can be identified in schedule. So we, like all other areas of software engineering, a number of basic principles guide the software project scheduling also. Compartmentalization, interdependency, and time allocation. Compartmentalization means the project must be compartmentalized into a number of manageable activities and tasks. And to accomplish this compartmentalization, both product and process, needs to be decomposed. What about interdependency? The interdependency of each compartmentalized activity, a task must be evaluated and determined. So some tasks must occur in sequence, while others can occur in parallel also. So some activities cannot commence until the product produced by another is still awaited. Other activities can occur independently also. What about time allocation? Each time to be scheduled must be allocated some number of work unit, like person months, etc. Person's day of effort. So in addition, each task must be assigned start date and completion date that are function of the interdependency and whether work will be connected on a full-time or part-time basis. Then effort validation. Every project has a different number of staff members, of course. So as time allocation occurs, the project manager must ensure that no more than allocated number of people have been scheduled at any given time. Responsibilities needs to be defined. Every task that is scheduled must be assigned to a specific team members. And defined outcomes means every task that is scheduled should have a defined outcome also. Milestone should be defined. Every task or group of tasks should be associated with certain milestones. PERT and CPM, program evaluation and review technique, and critical path method, PERT and CPM. These are two project scheduling methods that can be applied to software development also. We also have a Gantt chart. Gantt chart can also be used. Performance evaluation, review technique for this, critical path method, and Gantt chart. What is the meaning of software estimation? Software project estimation, it includes the estimation of cost and effort. So we are basically interested in cost and effort. There are variables like human, technical, environment, and political, which may affect the cost and effort of the software we are going to develop. So software project estimation can be transformed from black art to a series of systematic steps that may provide estimates with acceptable risk. And to achieve reliable cost and effort estimate, there are a number of options. Say we have delay estimation until late in the project. If we delay estimation, obviously we are not able to achieve 100% accurate estimates after the project is complete. The base estimates are on similar projects that have already been completed. This can be seen. And we use relatively simple decomposition technique to generate project cost and effort estimates. And we use one or more empirical methods for software cost and effort estimation. The decomposition technique can be, divide and conquer approach to software project estimation. So by decomposing a project into major functions and related software engineering activities, this cost and effort estimation can be performed in a stepwise fashion. These are the empirical estimation models that can be used to complement the decomposition technique, and it offers a valuable estimation approach. The model is based on, say, historical or experience data of this form, and D is the one of the estimated values of, say, effort, cost, project duration, and this VI, these are the selected independent parameters. So D is the function of VI. Effort, cost, project duration, VI can be KLOC or FP. For example, for number of people, we can have line of code divided by duration into LOC by PM, person, month, line of code. So precise estimation is difficult, and you can have three estimates. Like you can have one optimistic, pessimistic. This most likely and pessimistic and optimistic can be combined. This is how we can evaluate SOPT plus 4 into SM plus S PES by 6. This is optimistic, this is most likely, and this is pessimistic. Explain the rule that should be followed by or followed for creating the analysis model. So there are certain rules for creating the analysis model. We are talking about software analysis. This is the design part. Software analysis, software design. Analysis. First, the information domain of a problem must be represented and well understood. And the function that the software is to perform must be clearly defined. Then comes the behavior. The behavior of the software as a result or consequence of external event. This must be represented. And the models that depict information, function, behavior must be partitioned in a manner that would uncover details in a layered fashion, hierarchical fashion. And the analysis process should move from essential information toward the implementation detail, because ultimately we are going to make the design and then to implement it. So if we apply these principles, the analysis or analyst, the person who does it, approaches a problem systematically. So the information domain is examined so that the function may be understood more precisely and completely. What are the design quality guidelines? Design quality guidelines. So design quality guidelines, these are the design quality guidelines. First is that the design should exhibit an architectural structure that has been created using some recognizable design patterns and is composed of components that exhibit good design characteristics and that can be implemented in an evolutionary fashion, thereby facilitating the implementation and testing. The design should be modular. For example, the reason being the software should be logically partitioned into elements that perform specific functions in some functions. The design should contain distinct representation of data, architecture, interface, and components, that is modules. These are all modules and they should be represented distinctly. The design should lead to data structure that are appropriate for the objects to be implemented and are drawn from recognizable data patterns. The design should lead to components that exhibit independent functional characteristics. Components. The design should lead to interfaces that reduce the complexity of connection between the modules and the external environment. That is the cohesion and coupling. Cohesion should be strong. Coupling should be as least as possible between the modules. The design should be derived using a repeatable method that is driven by information obtained during the software requirement analysis. Hence, design should be traceable to the requirements. Can be first of all high level design, then you can have a low level design. High level design is sometimes also known as the architecture. What are the characteristics of good design? As we have seen, the characteristics of good design, let us see a few more. The three characteristics that would serve as a guide for or how can we evaluate a good design. First is the design must implement all the explicit requirement contained in the analysis model, and it must accommodate all the implicit requirements also, explicit also and implicit also. The design must be readable, understandable, guide for those who generate code and for those who test and subsequently support the software, who are going to maintain the software. The design should provide a complete picture of the software, addressing the data, the functional and the behavioral domains from an implementation perspective. Explain unit testing. What is unit testing? Unit testing focuses verification effort on the smallest unit of software design, that is a unit or a module or a software component. Using this component level design description as a guide, important control paths are tested to uncover errors within the boundary of the module. And the relative complexity of test and uncovered errors is limited by the certain or constrained scope established in the unit testing. Unit testing is white box oriented because we know the code, we know the inside, and the step can be connected in parallel for multiple components. If this is a module, we can have test cases, interfaces, local data structure, boundary condition, independent path, error handling paths. All this can be included to test a module. The module interface is tested to ensure that the information properly flows into and out of the program and unit under test. This is the module. So the local data structure is examined. Local data structure, first interface testing, local data structure testing is examined to ensure that the data stored temporarily maintains its integrity during all steps in an algorithm's execution. Boundary conditions are tested to ensure that the module operates properly at boundaries established to limit or restrict processing. Then the independent paths or basis path through the control structure are exercised to ensure that all statements in the module have been executed at least once. And finally, all error handling paths needs to be tested. Then comes the system testing. See, unit testing, then integration testing, and then comes the system testing. So system testing is actually a series of different processes whose primary focus or purpose is to fully exercise the computer-based system or the software being made. Although each test has a different purpose, all work to verify the system elements that have been properly integrated and perform the allocated functions. So a software engineer should anticipate potential interfacing problem like design error handling path that test all information coming from other elements of the system. Conduct a series of tests that simulates bad data or other potential errors at the software interface. Records the result of test to use as evidence to fingerpoint if fingerpoint has to occur after this. Participate in planning and design of system tests to ensure that the software is adequately tested. We can have recovery testing, security testing, stress testing, performance testing. Explain about software quality assurance. We need to assure that the software quality is there. The process are followed which leads to a quality product. The software quality is defined as the conformance to explicitly stated functional and performance requirements, explicitly documented development standards, and implicit characteristics that are expected of all professionally developed software. So SQA does what? It encompasses a quality management approach, effective software and engineering technology, that is methods and tools, formal technical reviews that are applied throughout the software process, multi tiered testing strategy, control of software documentation and changes which are applied to it, a procedure to ensure compliance with software development standards whenever applicable, and measurement and reporting mechanism. So SQA activities, various activities are performed or facilitated by an independent SQA group, Software Quality Assurance Group. This is independent. So first, it prepares a SQA plan for a project. It participates in the development of the project software process description, reviews software engineering activities to verify compliance with the defined software process, and then audits designated software work products to verify compliance with other defined as part of software process, and ensures that the deviations in software work and work products are documented and handled according to the documented procedure. And also it records any non-compliance and reports to senior management. Define or describe the 4 layers of software engineering. Software engineering encompasses a process, management of activities, technical methods, and use of tool to develop software products. Tools, methods, process, and quality focus. So the bedrock that supports the software engineering is the quality focus. The foundation of software engineering is the process layer. This is the process layer. Software engineering process is the glue that holds the technology layers together and enables the rational and timely development of computer software. So process defines a framework for a set of key process areas, KPAs, that must be established for effective delivery of software engineering technology. The key process areas form the basis for management control for software projects and establish the context in which the technical methods are applied. So work products, these are models, documents, data, report, forms, etc. These are produced. And milestones are established, quality is ensured, and changes is properly managed. The software engineering methods, we have talked about the process. Now we'll talk about method and then tools. So software engineering method provide technical know-hows, how to build a software. Method encompass a broad array of tasks that include analysis, design, construction, testing, and support. So software engineering methods, it rely on set of basic principles that govern each area of technology and include modeling activities and other descriptive techniques. So software engineering tools now, they provide automated or semi-automated support for the process and the method. When tools are integrated, so that the information created by one tool can be used by another, a system for the support of software development called CASE is established. Computer aided software engineering. This combines software hardware and software engineering database, a repository containing important information about analysis, design, program, construction, and testing, to create a software engineering environment analogous to CAD and KE for hardware. Explain data objects. A data object is a representation of almost any composite information that must be understood by software. By composite information, what we mean is that has a number of different properties or attributes. So the width, a single value would not be a valid data object, but dimensions incorporating height, width, and depth could be defined as an object. So a data object can be an external entity, like which produces or consumes a thing, like report on display. An occurrence is a telephone call, an event like an alarm, a role like a salesperson, or an organizational unit like a accounting department, or a place like a warehouse, or a structure like file. For instance, a person or a car can be viewed as a data object in the sense that either can be defined in terms of set of attributes. So a data object description incorporates the data objects and all of its attributes. Data attribute. What are data attributes? We have seen the data object. So attributes define the properties of data object and take on one of these different characteristics. So these are 3 different characteristics. They can be used to name an instance of the data object, describe the instance, or make reference to another instance in another table. And in addition, one or more of these attributes must be defined as an identifier. That is, the identifier attribute becomes a key when we want to find an instance of the data object. So in some cases, value of the identifiers are unique, although this is not a requirement. And referring to the data object car, the reasonable identifier must be some ID number. So the set of attribute that is appropriate for a given data object is determined through the understanding of the problem context. For example, the attribute for car might serve well for an application that would be used by the Department of Motor Vehicles, but these attributes would be useless for an automobile company that needs manufacturing control software. L is the reason of failure of software project. why a software failure happens, or why a software project fails. There are many reasons. First of all, why this software is delivered late. Most can be traced with certain, there can be roots. These are root causes. First of all, unrealistic deadline established by someone outside the software development group and forced on the managers and practitioners in the group. Then changing customer requirements always that are not reflected in schedule changes. An honest underestimate of the amount of effort or the number of resources that will be required to do the job. Say predictable or unpredictable risks that were not considered at all when the project was commenced. Technical difficulties that could not have been foreseen in advance. Human difficulties that could not have been foreseen in advance. Miscommunication among project staff that results in delays. Failure by project management to recognize that the project is falling behind schedule and lack of actions to correct the problem beforehand. What are reactive and proactive risk strategies? Reactive, proactive. Reactive risk strategies follows that the risks have to be tackled at the time of their occurrence. No precautions are to be taken as per this strategy. So they are meant for risk with relatively small impact. What about proactive? Proactive risk strategies follows that the risk has to be identified before the start of the project. And they have to be analyzed by assessing their probability of occurrence, their impact after occurrence, and the steps to be followed for its precaution or its stoppage. So they are meant for a risk with relatively higher impact. L is the factor on which the success of software project depend. The various factors, first of all, proper project planning, cultivate a zero defect mentality, proper understanding of customer requirement, timely execution of various project phases, addressing the root cause, efficient risk management, database approach, use the correct tools, enlist top management support, local process owner support, involve rank and file, manage resistance to change, leadership. Even if you explain Six Sigma, ISO, McGraw-Hill quality factor, it would be correct. So these were a few questions. We are taking the descriptive questions on engineering. So we'll take more. Till then, thank you so much. Take care.